Hi, I am Raghavan, chemistry faculty from ALPHORES colleges. So I welcome you all for the ALPHORES chemistry e-learning classes, session 36th. Okay, in this session, so we will go for the revision of atomic structure chapter only. So in that we have to take some important conceptual questions revision. Okay, so some important conceptual questions. Yesterday we had discussed some numericals. Similarly, today also let us discuss some more numericals based on the electron configuration and magnetic properties of the elements. Okay, so let us take up the first one is see, magnetic moment we explained. Okay, what is, once again let us take the revision of the magnetic moment. The magnetic moment of a paramagnetic substance can be calculated, that is mu is equals to under root n into n plus 2, under root n into n plus 2 Bohr magneton units. Okay, where n is equals to number of unpaired electrons, number of unpaired electrons, number of unpaired electrons. Okay, so that is the concept of this formula. That is, this is used to calculate magnetic moment of the paramagnetic substances, where n stands for what? Number of unpaired electrons, that we should remember. Suppose if there is no unpaired electron in that species, so then we can say simply it is a diamagnetic substance. So paramagnetic, the paramagnetism of the substance is due to the presence of unpaired electron. Paramagnetic behavior is due to the presence of unpaired electrons. Unpaired electrons. Okay, and diamagnetic behavior is due to absence of unpaired electron. Absence of unpaired electron. Absence of unpaired electrons. That is, what is the meaning of absence of unpaired electrons? The orbital may be completely filled or they may be vacant. Okay, due to the absence of unpaired electrons, we can say that it is diamagnetic. Presence of unpaired electrons, we can say that it is paramagnetic in nature. That means it is attracted towards the magnetic field. Okay, so that is a basic concept of paramagnetic and diamagnetic. Ferromagnetic is present, but it is a different concept. That is, as the number of parallel spin unpaired electrons increases, the substance is strongly attracted towards the external magnetic field. That behavior is called ferromagnetic. Okay, that is, presence of more number of parallel spin unpaired electrons causes ferromagnetism. Okay, that is a different one. Now this is the basic idea to find out the paramagnetic behavior. Okay, now let us go with some examples. Yes, so the first question based on this magnetic moment. Question is, which among the following is paramagnetic in nature? Which among the following is paramagnetic in nature? Which among the following is paramagnetic in nature? That is the question. Okay, so now the options let us give. Scandium plus 3. Second option, titanium plus 4. Third option, copper plus 1. Fourth option, copper plus 2. Copper plus 2. So identify which among the following is paramagnetic in nature. So okay, so to identify the paramagnetic nature, we have to identify the first unpaired electron must be present in that. Okay, so which of the following contains unpaired electron? So scandium plus 3. Scandium atomic number is 21. Okay, so the configuration of scandium is, that is argon 4s2 3d1, 4s2 3d1 plus 3 means the scandium, here I will write argon 4s2 3d1. Okay, 4s2 3d1. I am writing the, I wanted to show the valency shell. Okay, plus 3 means it can lose 4s2 electrons first and 1 electron from the 3d orbital. So what is the configuration of this scandium? So 3d orbital is completely vacant. Okay, because no electron left in this, so it is vacant, means it is a diamagnetic. Okay, it is a diamagnetic, you should remember that. Titanium plus 4. Titanium atomic number is 22. Okay, scandium, titanium, vanadium. So titanium is 22. 22 means argon 4s2 3d2. Argon 4s2 3d2. It is plus 4, means it loses 4s2 electrons completely and 2 d electrons also lost. So therefore the d orbital is again vacant in this also. So argon, then 3d 0. So again it is a diamagnetic because no unpaired electron in this. Copper plus 1. Copper plus 1 configuration. Copper atomic number is 29 and we know that copper shows anomalous electron configuration. Okay, deviation from the Hund's rule, deviation from the Aufbau principle. Okay, so therefore according to the significance of the Hund's rule, so the completely filled d orbitals are more stable than the normal configuration. So therefore it shows 4s1 3d10. 4s1 3d10. Since it is plus 1, it can lose outermost 4s electron. So the 3d orbital is completely filled. So argon 3d10. Argon 3d10. So since orbital is completely filled, or 5d orbitals, so therefore no unpaired electron is available. Hence it is also a diamagnetic. It is also a diamagnetic. Now copper plus 2. Copper plus 2. That means it can lose 1 electron from the outermost 4s orbital and 1 more electron from the 3d orbital. So how many electrons left? 3d 9 is left. 3d 9 means we have 5d orbitals, 1 2 3 5. All the 5d orbitals, 3d 9. So 9 electrons, 1 2 3 4 5 6 7 8 9 electrons. Okay, how many unpaired electrons are there in Cu plus 2? 1 unpaired d electron is left. That means that is argon. Okay, 3d 9. Argon 3d 9 means how many unpaired electrons are there? 1 unpaired electron. 1 unpaired electron. Yes. Calculate magnetic moment here only. Magnetic moment is equals to under root n into n plus 2. That is 1 into 1 plus 2. 1 plus 2, that is equals to root 3. Isn't it? Root 3. Okay. So root 3 Bohr magneton units. Bohr magneton units. So that is 1.732. That is equals to 1.732 Bohr magneton units. Bohr magneton units. Okay. So that is the way to calculate, to identify the paramagnetic substance and diamagnetic substance, and we can calculate the magnetic moment of this substance also. Okay. So due to the presence of unpaired electrons, we can calculate magnetic moment of the unpaired electrons. Okay. That is for paramagnetic substances. When there is no unpaired electrons, simply we can say that they are diamagnetic. Okay. That is one important, very important concept you should remember. That is determination of magnetic moment of the substances. Okay. So now let us take another example. Okay, this is one example. I think it is clearly understood. Okay, so it is first one, second one, third one we explain independently, and we explain Cu plus 2 how the configuration is 3d 9 and how many unpaired electrons are there and how we are calculating the magnetic moment. Okay, in detail we explain that. Okay, next molecule, next example, we let us proceed. Okay, next example. Okay, let us proceed with the next example. Yes, which electron configuration is not possible? Which electron configuration is not possible? Okay, options are given like this. First option, 2p6. Is it possible or not possible? That you have to exercise. Third option and fourth option. Okay, first option is given 2p6. Second option is 2d5, 2d5. Third option is 3s1, 3s1. Fourth option is 4f12 is given. So which electron configuration is not possible? Which configuration is not possible? Okay, so it is given as it is 2p, it is 2d, it is 3s, it is 4f. So is it the possible 2d is possible? N is equals to clearly says that it is 2. And what is the L value? L is equals to for d sub shell it is 2. From the quantum numbers we understand. So that is L is equals to 0 for s orbital, that is s sub shell. L is equals to 1 for p sub shell. L is equals to 2 for d sub shell. Okay, that is L is equals to 2, that is representing d sub shell. Yes, that means N value is equal to 2 and L value is equal to 2. Is it possible? So L value is always equal to, L is equal to N minus 1 always. You should remember that. We know that. So that is azimuthal quantum number value. That means the subshell value always equal to N minus 1. It cannot be equal to N value. So therefore 2D subshell does not exist at all. So therefore the answer is this. Which electron configuration is not possible? 2d5 configuration is not possible because the subshell does not exist. Why it does not exist? Because L value always equal to N minus 1. So the L value must be smaller than N value. Okay, smaller than N. Okay, that means 0 and 1 is possible in the second orbit but not 2. Okay, that is why 2D configuration does not exist at all. Not only that one, let us observe this. 1p, 2d, 3f orbitals does not exist. 1p, 2d, 4f orbitals does not exist. Why? Because here n is equals to 1 and L is equals to 1. Here n is equals to 2, L is equals to 2. Okay, we know that. Here n is equals to 3, L is equals to 3 because L is equals to 3 for f orbital. Okay, when L is equals to 3, that represents f orbital. So that is n value is equal to L values in these 3. Okay, but L value always it must be equal to n minus 1. Okay, we should remember that L always equal to n minus 1. It cannot be equal to n values. Therefore, all these 3 subshells does not exist at all. That is another important point you should remember. Okay, so all these are the important concepts for the examination, objective examination point of view. All these concepts are important for all the objective examinations, particularly for EAMCET, JEE mains and BITSAT examinations. These are the fundamental parts. Okay, right. That is one question. Next. Next one is, yes, which has the highest number of unpaired electrons? Which has highest number of unpaired electrons? The question is, which has highest number of unpaired electrons? Highest number of unpaired electrons. Yes, the options let us take up. Options. Highest number of unpaired electrons. Options are given. What are the options we have? Manganese, Mn plus 5 plus 3 plus 4. Mn. Second option, Mn plus 5. Third option, Mn plus 3. Fourth option is given, Mn plus 4. The question is, so which has highest number of unpaired electrons? Highest number of unpaired electrons. Okay, manganese atomic number. Manganese atomic number is 25. The normal configuration of manganese, we can say it is argon. It covers 18 electrons, that is core shells. Okay, that is 18 electrons. Then 3d5, 4s2. That is manganese 25 normal configuration. Okay, that is, this is the manganese configuration. That is 3d5. It has got maximum number of, highest number of unpaired electrons. Okay, so therefore let us write here argon 3d5 4s2. 4s2 means 5 unpaired electrons are there in this. Next one, plus 5. Plus 5 means it has lost first 4s electrons completely, 2 electrons are gone, and 3 electrons from the 3d orbital. Now the configuration of this is argon. So 2 electrons are gone from this and 3 electrons from this, so 3d2. That is the configuration. That means it has got 2 unpaired electrons. Now Mn plus 3. Mn plus 3 means it loses 2 electrons from the outermost shell and 1 electron from the 3d orbital. So argon 3d4. Argon 3d4. That means 4 unpaired electrons are present in this. Next, Mn plus 4. Mn plus 4 means it loses 2 electrons from the 4s orbital and 2 electrons from the 3d orbital. So it is argon 3d3. Argon 3d3. That means it has 3 unpaired electrons as per the question. Okay, so which has the highest number of unpaired electrons? That is first option. Which among the following has highest number of unpaired electrons? Is plus 5. So plus 5. Okay, that is we understood. So from the configuration we can notice that manganese atom is having 5 unpaired electrons. Therefore, as per the question, this is our answer. Okay, now extend the question from here. So which has highest magnetic moment? Highest magnetic moment means the species should have the greater number of unpaired electrons. As the number of unpaired electrons increases, the magnetic moment also increases. So therefore, among these 4 options, the highest magnetic moment is first option only, because it contains 5 unpaired electrons. Therefore, manganese atom has 5 unpaired electrons. Therefore, because of the maximum number of unpaired electrons, its magnetic moment is also highest. Okay, that is why like that we can understand, we can identify the right option. Which has maximum number of unpaired electrons, that is first option. Which has highest magnetic moment, that is also first option, because highest number of unpaired electrons. That is one important point. Next one. Okay, next question is, the question I read like this. So which set has the same number of s electrons? Okay, which set has the same number of s electrons? That means s orbital electrons. Okay, let us, before going to discuss that question, so let us clear the board. Which set has highest number of s electrons? That means s orbital electrons. Highest number of s electrons. Okay, let us take up the first option. First option is carbon, copper plus 2, Zn. Carbon, copper plus 2, Zn. Okay. Second set, second option, that is copper, Cu plus 2, Fe plus 2, nickel plus 2. Copper plus 2, Fe plus 2, nickel plus 2, ion. Okay, all these are ions only. Okay, third option, let us see what is the third option. Okay, sulfide, nickel, zinc. Sulfide, nickel and zinc. Okay, fourth option, let us make it none of this. None of these. Okay, done. So the question once again, what is that question? The set has same number of s electrons. The set has same number of s electrons. That means, for example, if you write the configuration, that means s orbital electrons like 1s2, 2s2, 2p6, like that. When we write the configuration, you have to count the total number of s electrons. So total number of s electrons must be equal. Same number of s electrons. Okay, same number of s electrons. Let us do this one. Okay, so first option, we are discussing about first option. We have carbon, copper plus 2, okay, and Zn. Okay, carbon electron configuration 1s2, 2s2, 2p2, s electrons are 4. So this carbon is having s electrons 4. Let us write here s electrons 4. Copper plus 2. Copper plus 2 is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. Okay, we know that it is plus 2. Plus 2 means what? It loses outermost 4s electron. Lost. Okay, and one more electron from the d orbital is gone. This is the net configuration of copper plus 2. How many s electrons are there? 1s2, 2s2, 3s2. Total we have 1, 2, 6. Okay, so 6 electrons are present in this copper. So we have 6 electrons only, 6 s electrons. Okay, let us discuss about zinc. Zinc configuration atomic number is 30. So that is, let us do here only. So it is 3d10 4s2, 3d10 4s2. So zinc atom, this is zinc atom, zinc atomic number 30. This is zinc. How many electrons are there? 1, 2, 3, 4. So 4 to the 8 electrons are there in this. In this we have 8 electrons. Yes, s electrons are not equal. 4 electrons, 6 electrons and 8 electrons, they are not equal. Okay, that is a point we understood. Yes, it's not the first option. Let us take the second option. Already we had that copper plus 2, we already calculated 6 electrons. Okay, copper plus 2 has 6 s electrons. We have to discuss about Fe plus 2. Fe plus 2. Okay, Fe plus 2. Fine. Iron atomic number is 26. Iron atomic number is 26. Let us write first 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Sorry, 4s2, 3d6. That is a normal configuration of iron atom. Normal configuration of iron. What he said, iron plus 2. Plus 2 means what? It is going to lose outermost 4s electrons completely. So 4s 0 now. Okay, now we have to count the s electrons. Yes, the configuration, it is Fe plus 2. Fe plus 2. Now s electrons 1, 2, 3. That is 3 to the 6 electrons. Yes, copper plus 2 has 6 electrons and iron plus 2 also contain 6 s electrons. You can clearly find out. Okay, 4s2 electrons are lost because it is iron plus 2 ion. So that is, so it is after losing that. So 1s2 having 2 electrons, 2s orbital also contain 2 electrons, 3s orbital also contains 2 electrons. Total s electrons are 6. Done. That point is clear. Now let us work on nickel plus 2. Nickel atomic number is 28. Okay, nickel atomic number is 28. 28 means what is the normal configuration of nickel? 4s2 3d8. That is the normal configuration. 4s2 3d8. So it is plus 2. Nickel plus 2 means it is going to lose outermost electrons. That is s electrons are losing. So it is nickel 4s0. Yes. How many electrons? S electrons. 1s2, 2s2 and 3s2. Yes, again it is 6 electrons. Yes, nickel plus 2 also contains 6 electrons. Answer will be the second option. Okay, so why we are discussing slowly? We are explaining each ion with the normal configuration and ionic configuration, and we are identifying how to calculate the s electrons. Okay, all these 3 species contain equal number of s electrons, that is 6 electrons, 6 electrons and 6 electrons. Is it clear to all of you? Yes, the given option, the second option is correct answer for the given question for us. Okay, next let us move to the next option. Next option. Yes. Okay, the next one is, yes, the ion that has 18 electrons in the outermost shell. The ion that has 18 electrons in the outermost shell. The ion that has 18 electrons in the outermost shell. 18 electrons in the outermost shell. Remember, the ion that has 18 electrons in outermost shell. Outermost shell. Yes. What are the options for this? First option, second option, third option and fourth option. The ion that has 18 electrons in outermost shell. Options are copper plus palladium, copper plus 1, palladium. Next one is manganese plus 4, Mn plus 4 and zinc atom, Zn, zinc atom. Okay, these are the 4 options are given. So what is the question? The ion or the atom, the atom that contain 18 electrons in the outermost shell. The ion that contains 18 electrons in the outermost shell. So they said that the atom which contain 18 electrons, okay, automatically, logically, the 2 ions can be removed easily. Okay, the atom, he said that in the question itself, the atom which contain 18 electrons, okay, automatically the 2 ions will go off. Now you have to find whether this answer or this answer. In the outermost shell, they said, in the outermost shell, okay, that is one point you have to remember, right? Palladium configuration, palladium atomic number 46, palladium atomic number 46, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2, 3d10, okay, 3d10, 4p6, 5s2, 5s2, 4d8. This is the normal configuration we wrote for palladium 46, 10, 20, 30, 46. Yes, electrons are matched. That is a normal electron configuration of palladium 46. And remember, according to the significance of the Hund's rule, the completely filled d orbitals are more stable. So therefore, the complete 5s electrons now transferred into the 4d orbital. Okay, 4d orbital. So therefore, the complete 4s electrons transferred into the 4d orbital in order to get completely filled d orbitals. That is the configuration for palladium. Very, very important question it is. Okay. So how many outermost 5s electrons? 5s electrons are completely 0 because all the 2 electrons, s electrons, transferred into the 4d orbital. Now, so this is 5s, no electrons are there in this. Now automatically the 4th shell will become outermost shell. So in the 4th shell, what is the electron configuration? That is our 4s2. Done. Next 4p6. Okay. Next we have 4d10, 4d10. Yes, total how many electrons are there in the outermost shell? Because 5s orbital is 0, it has gone 0. So now, so automatically the 4th shell will become the outermost shell. For that, how many electrons are there? 2 plus 6, 8, 8 plus 10, 18. Yes, the palladium atom has 18 electrons in its outermost shell. So therefore, the answer will be the second option. Okay, so the atom which contain 18 electrons in the outermost shell, which contain 18 electrons in the outermost shell, that is palladium atom. Because atom is asking, not ions. Automatically, logically we can remove the first option and third option because they are ions. So answer may be the second option or third option, fourth option. So now answer will be palladium 46. It contains 18 electrons in the outermost shell. What about why not it is zinc? Let us find out the zinc. What happens? Zinc atomic number is 30. So zinc atomic number is 30. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2 and 3d10. 4s2, 3d10. This is outermost shell. That is outermost orbit, 4th orbit. This is last but one shell. So outermost shell contains only 2 electrons. Outermost shell contains 2 electrons. So the zinc 30 contains 2 electrons in the outermost shell. Okay, so that is why zinc contains 2 electrons in the outermost shell and palladium contains 18 electrons in the outermost shell as per the question given. Okay, like that we have to analyze. Okay, so that is another important concept for this. Like this we can calculate. Next one. Okay, next next question is the transition metal X Next question, transition metal X. The transition metal X has the configuration argon, has the configuration 3d4, has the configuration 3d4, has the configuration 3d4 in +3 oxidation state, in +3 oxidation state. I repeat again the question. Okay, the transition metal X has the configuration argon 3d4 in +3 oxidation state. In +3 oxidation state, it is possessing the configuration like this. Okay, it is possessing the configuration like this. Then what is the atomic number of the element X? What is atomic number? What is atomic number, that is Z, of element X? What is the atomic number of the element X? You got my question? Is it clearly understood? Once again, listen. A transition metal X, okay, has this configuration in +3 oxidation state. That means X is equals to X +3. In this X +3 configuration is given argon 3d4. That is the configuration. So what would be the atomic number of that element X? Okay, now the options we can say like this. Options we can say. What are the options we have? Say for example 25, and second option make it 26. Third option say it is 29, and fourth option is 19. So automatically the fourth option goes cancelled because the transition metal starts from scandium 21 onwards. So it cannot be 19 at all at any cost. So therefore automatically the fourth option will be go wrong. Okay, now you have to identify among these three the right answer. So X +3 has how many electrons right now? So argon atomic number, argon 18, it covers 18 electrons. 18 plus 4 electrons, 22 electrons are there. Okay, 80, that is X +3 has 22 electrons. 22 electrons. Try to understand it clearly. So X, the configuration of X in +3 oxidation state has this many electrons. Okay, that means X +3 has 18 plus 4, 22 electrons. Okay, after losing 3 electrons, isn't it? In a neutral atom, okay, so that is X +3. Okay, now it is gaining 3 electrons. After gaining 3 electrons, then it becomes neutral X atom. Now it is 22 electrons are already present. Now whatever it may be, whatever it lost, so the 3 electrons are gained back. So then it becomes X25. So the atomic number of that X metal is 25, like this. Because after losing 3 electrons, the configuration is this much. Okay, suppose to make it a neutral atom, so whatever the electrons lost, you have to supply it back. So 3 electrons is given back to the X +3 ion. So therefore 22 plus 3 electrons, so total it becomes 28. So now X is a neutral metal atom now. Okay, and its atomic number is 25. The atomic number of that metal atom is 25. Okay.